Alrighty guys, so we're now in 1987, AB question number 2. We're going to go through these questions, and then finally after this question we get to the first BC one. I can't wait. So let's go ahead and do this quickly. Let f be a function given as f of x equals 3 cosine shown above. Okay, so that's just this is the picture, and it says here, write the equation of a line passing through points P and Q. Oh wow, that's like algebra 1. Cool. So for A, we want to find out the equation of line PQ. Okay, simple enough. We need to know the slope though. I don't see, we have the y-intercept, right? So it's a plus 3, the b is 3, but this is b, but we need the y-intercept, I'm sorry, the slope. So we're going to do y2 minus y1 over x2, which is pi over 2, minus x1, negative 3 over pi over 2. We can go ahead and simplify it to negative 6 over pi. Okay, so that's our slope. So negative 6 over pi x plus 3. The b is 3. Okay, awesome. That was super easy. Alrighty. That's part A. Part B. Write the equation of a line tangent to the graph of f at point Q. Show the analysis that leads to your equation. What the heck? Show the analysis? Did that mean to show the work? I don't know what that means. Okay, I'm just going to do the work. How's that? They just don't want the answer, I guess. So let's go ahead and put that. The equation for the line that's tangent to the graph of f. So we have to, at point Q, we have to find the slope of that, right? So we need to find f of point Q. Point Q is pi over 2. That's the x value. Let's go ahead and do that. What's the f? 3 cosine. So it's going to be, well, I'm going to first put f. I'm going to do this. F of prime of x equals to negative 3 sine, because derivative of cosine is negative sine. So f prime, I'm not sure how much work they want, so I'm going to try my best to be as thorough as possible. Negative 3 times sine of pi over 2. That's the same thing as negative 3 times 1, right? Sine of pi, yeah, it's 1, which is negative 3. And now we're going to go ahead and use this point slope formula, because I'm going to put the coordinate. Slope is 3, negative 3. I'm not sure. Okay, so it has to be that. Show the analysis. It must be this. I can't imagine them expecting more than this. I don't know what else they would expect. But okay, anyhow, there you go. B is really simple. And moving on to C. Okay. It wants to find the x-coordinate of the point on the graph of f between points P and Q, at which the line tangent to the graph of f is parallel to PQ. Read this one more time. It looks like it wants its mean value theorem. Okay, so this is just a mean value theorem. So I know I said this in a prior, oh my gosh, I can't write the letter M. Mean value theorem. I know I said this in a prior video, but just in case it's the first video you guys open up to, I'm going to explain what the mean value theorem states. The mean value theorem says the following. Assuming, of course, if here's the conditions, right? If you have a continuous, if you have a function that's continuous and differentiable between a to b, then there will always exist at least one slope of a point between a and b that's equal to the slope of the secant line from a to b, okay? So, in other words, there's going to be a slope of a point which is going to equal to the slope of the secant line from a to b, inclusive, right? Assuming, of course, it's continuous between a to b and differentiable. You can imagine, like, maybe like a absolute value equation where between these two lines, there's no point that has the same slope because it's not differentiable at that point where it should be. So it's very important you guys remember that. That being said, let's go ahead and dive in. C says, okay, so let's first find out let's figure out, we'll just pick us out. We'll do that one first, okay? We need to find the derivative, which I think I did earlier. Yeah, the derivative is negative 3 sine of x. So f prime of c is negative 3 sine of c. You don't have to use the letter c. I'm pretty sure it's fine if you leave it as x or whatever, but it's just, that's the notation. Everyone likes to do it. So if you want to use it as x, you can. Whatever, A, B, C, that's what you see. And then it's equal to the slope between, what's it about? Between P and Q. Oh, we did this already. The slope is, that was an A, right? The slope is negative 6 over pi. So even, this is easy, guys. Negative 6 over pi. So now we're just going to solve for C, or that value, okay? I'm going to divide both sides by negative 3. Sine, oh boy, I need a calculator for this. There's no way I can do it. Let me see, that's 2 over pi. No, I don't know this by a calculator. I'm going to use a calculator. Unless they want this. Unless they expect the answer to look like that. So it's the arc sine of 2 over pi, whatever the heck that is. Let's use a calculator. Arc sine 2 over pi. Okay. If I'm not mistaken, calculus requires minimum of 3 decimals. AP stats, sorry, requires 4. I'm going to use 4 decimals. I don't want to put fewer because they will penalize you if you have fewer decimals, but they won't penalize you if you have more. Okay, it's 0.6901. Okay. Is that between, what's the interval? Between, what is it? It's between, crap. Let me look at the picture. From 0 to pi over 2. Is that between 0 and pi over 2? Yes, absolutely. Okay. It's pi over 2 is approximately 1.5, so it's definitely in the middle. Alright, that's easy. That was not bad. Let's see what the next one says. Here it is. Let R be the region on the first quadrant bounded by the graph of f and line segment PQ. Write the integral expression for the volume of solid generated. Blah, 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 blah. Okay, solid revolution. Okay. What are we rotating? We're rotating this line. This is F, and then it says PQ. Okay, so I'm going to put, you know what? We get a different color. I'm just going to do shade the whole thing. I'm not good at drawing lines. Okay, we're rotating that. Okay. That's easy. About where? On the X or Y axis? About the X axis. Do not evaluate, even better. Okay, so we're rotating this around the X axis. We have to remember, guys, that what you're rotating is the way you get the volume is you're kind of subtracting 2 volumes, right? You're getting a volume of a weird thing like this, like a solid, weird, almost like a Hershey kiss kind of thing on the side, and then you're taking away this, you know, like almost like a cylinder, cone out of it. So you can imagine, not exactly a Hershey kiss, but kind of. That's hollowed out. I don't know. That's what it looks like. And this is a circular thing. So, okay, so that's a weird thing. So what you're going to do is you're going to take the volume of the bigger shape without any, like pretend this line isn't there. Just take the whole thing minus the volume of the inside. And then you get the volume of whatever's they're looking for, right? The hollow Hershey kiss. There is a formula. This is called the Washer method, right? The Washer method would be like the integral of pi times r squared minus r squared dx or dy, depending on the rotation, and r squared would be the outer radius, which would be the outer function, and little r squared is the inner radius or inner function. So basically it looks like this. Let me see if I can get a different color. I'm just reminding you guys in case you forgot, this entire line is r and this line is little r. You know, I'm just gonna use that formula. Screw it. I'm not gonna sit there and subtract 2 integrals. So it's going to be integral of pi of the bigger r. What's the bigger r? The bigger r, the value of the y, right? This entire line depends on the equation 3 cosine x. So that's what it is. So it's going to be 3 cosine x squared minus, and then this little r, the y value is dependent on the other equation, right? This equation, which we did this in part A. That's why they want us to do in part A. Minus this equation squared. So minus, wait, let me just zoom out for a minute. Negative 6 over pi. Do not distribute the negative because we're going to square it. So leave it like that. And then from 0 to pi over 2, since it's bounded in the first quadrant. So from here to here, right? So we're done. And that should be the answer. This would be the volume, right? So we'll put this to equals volume, whatever. I don't know. It says do not evaluate, so we'll leave it like that. Alrighty. I hope this question made a lot of sense, and we'll move on to the next one, the first BC one. I'm excited. So I'll see you guys in a minute.